here. These buttons are for controlling elements of the screen. So yeah, and one of our joysticks is a dud, unfortunately. So basically the sound card on the Raspberry Pi is output through this cable to a guitar amplifier. And it makes a pretty nice sound. You So you can see it's like, depending on the way that you press the joystick, the tone that comes out is different. So if we get like, so you can see like the note's very flat, and then when you hear it phases a little bit. So depending on which like, yeah, that's another one.
So one axis controls the tuning and phasing, and the second axis mixes between a triangle wave and a sawtooth wave.
So since it's like regular in each side, you can never remember which way it's supposed to
So moving horizontally corresponds to a perfect fourth jump, and moving diagonally this way is a whole step.
So yeah.
That's the one that burned out, didn't it?
Oh, yeah, there we go. There we go. But you can see, like, if I start here, or if I start here, the dud joystick. The physical way that I play a major scale is the same no matter where on it I start.
That's crazy.
So yeah, you can get in the major chords. Or anywhere you can start, it's the same interface. Or a minor chord. This note's not working, unfortunately.
But the lights are changing colors actually.
It's because the data line to control the lights is not connected. So you can like make noise on the data line and it will change the color of the lights.
Oh, that's fun.
The goal with this lighting system is we started writing the software, but it's not actually hooked up yet. Is we have an Arduino Micro that's going to basically light up in one color the notes that are in key, and in a second color the notes that are out of key. So not only do you have this pattern to work with, but you have this sort of visual representation of, oh, if I just want to jam, like I can, be here. And that's all sort of about making it easy to play nice sounds.
Right. One other idea we had early on was to have like a guide where you could like import a MIDI file and it would light up the notes in order to play the songs. It can teach you to play new songs because it's a new interface. So having good user feedback is important.
Yeah, or having a sort of like you can play one note and then it's like, oh, if you add these two notes, that's a major chord. So they sort of guide you through like learning the structures.
Right.
And what's cool about this sort of unbiased musical lab is that it starts to expose the musical structures in songs. So you can start to see like, oh, like this is the pattern for a chord that keeps coming up and.
Right. When we were playing it with it during our first demo, I was like, hey, this is like, just was playing a root motion that's really common in music, and it always shows up as like a really nice geometrical repeating pattern. And those geometrical repeating patterns are easy to memorize, they're easy to internalize, and since those things repeat so often in music, it sort of teaches you to recognize the things in music that repeat themselves, because they always show up the same on this instrument. So it's sort of
Question mark.
Yeah.
no. We have the synth patch with multiple notes, and our earlier demo was working with multiple notes, but the script that converts the analog values to digital values, or the script that takes the digital values and sends them to pure data, we don't have the logic to like kick out one note in the synthesizer and put in a new one.
Yeah, so there's that's no constraint of the hardware. It's just we haven't finished writing the software yet that can handle multiple notes.
Yeah.
That's next on the list.
Next on the list.
Yeah.
Any question? Oh wait, we've got one hard thing and one cool thing. So one of the hard things initially was, especially during the beginning, was latency. So having good latency for a digital system in music is especially important, because even if there's like a very slight delay between when you press the button and when you hear the note, it creates dissonance when you try and keep things to a tempo or time things with other musicians. So it's really important to have very tight latency.
The like theoretical maximum latency that you can't notice is about 10 milliseconds. So that was our like goal.
Yeah, and like especially in the early design with the PSOC firmware and communicating PSOC to Pi, all of our design decisions were pretty much based around how can we get the lowest latency possible. That's why we went with SPI over some of the other communication protocols, because it was the fastest one we could find. We were like in the very beginning we were doing like 10-bit ADC values, and we switched to 8 because it requires half as much communication to get the full key layout back to the Pi.
I think the cool thing is that this even works at all is converting 116 analog signals like 2,000 times a second, which is ridiculous.
Yeah.
So PSOC does a pretty decent job.
Yeah, PSOC made the job a lot easier, because like every time there was a couple times when we were like change the hardware interface, and so instead of having to like rewire everything, we just like move some blocks in the PSOC code and re-upload it, and it does it all with a combination of like reconfigurable digital logic like you would find on the FPGA, and really smart reconfigurable analog routing. So it can route any pin on the PSOC to any digital or analog resource on the inside. It's very flexible. Yeah. So I would encourage you to experiment with it.
Okay. Is this the Cypress PSOC that we have?
Is
this the regular one we had from the camp? Is that what you guys
this
use?
Is actually, yes.
The stock?
The one that we used in the original, when we were originally demoing this with like on a breadboard, was the one I got from the demo. And then eventually we ordered like a surface mount chip.
Yeah,
and
yeah.
soldered it.
Okay.
But yeah, that's...
Very cool.
So you did come to the demo.
I did come to the demo. I learned how to do everything.
Took something away.
And then then it turned into this.
That's awesome.
We'll be telling them that, thank you.
Oh, thank you. Yeah, maybe we can get like on their website.
Exactly.
This will be. This is great.
Sometimes it's fun to like mess it up. Yeah, you can play with it all you want. It's pretty fun. Yeah, so there's this guy, the Monotron guy. There's like this one-man operation in New York that builds instruments like this, not with this layout. It's like a square layout, I believe. And he has a profitable business just building these on his own. So it's definitely a marketable idea.
How much does he charge for something similar?
I don't know. Do you know off the top of your head?
I think for like $800.
Another shot with the lights.
We're gonna Oscars on you guys.
You have a poster